class, I have completed experiment number 1 under volumetric analysis. Today I am going to the discussion one more experiment in volumetric analysis. Only I have changed the strength of Mohr salt solution. In last experiment was to prepare m by 20 Mohr salt solution. With the help of this solution, determine molarity and strength of given KMnO4 solution. Today I have changed the strength. Strength is m by 30. In last class I have discussed m by 20 Mohr salt solution. So first of all, in this experiment, your work you have to determine how much amount of m by 30 Mohr salt solution is dissolved in 250 milliliter of water. Okay. Molarity formula, everyone knowing, m equal to Wb into 1000 divided by Mb into V in ml, where Mb indicate the molar mass of Mohr salt. In last experiment we had to calculate the molar mass of Mohr salt is 392 gram per mole. Mb equal to molar mass of Mohr salt. Calculated on that day 392 gram per mole. Value of m already given in the experiment 1 by 30. So put the value of m 1 by 30 equal to Wb going in the calculation into 1000 divided by Mb molar mass 392 into V 250 ml. After calculation, it becomes Wb into 30 into 4 equal to 392 and Wb equal to 392 divided by 30 into 4. After calculation, it becomes 3.26 gram. So first of all, your work you have to weigh 3.26 gram of Mohr salt through the physical balance. Okay, so I am going to weigh 3.26 gram of Mohr salt through the physical balance. I am going to weigh 3.26 gram of Mohr salt. In left side I have put the weight, right side chemical. Okay, actually it is in the some of the deflection is coming in left side. This indicate that Mohr salt is heavier than weight, so that a small amount of Mohr salt is required to be removed out from left side. So Siddheshwar, थोड़ा सा निकाल लेना है. ओके, नॉट चेक. Now some more amount is also required. Yes. Okay. Yes. In this experiment, a student need to prepare solution yourself. No ready-made solution is in the lab. Okay. Now, This needle in the straight line, this indicates that chemical that is with more salt, that is weight is 3.26 grams. So we will take this chemical in one of the beaker. Okay. Yes. Just come this side. Dissolve more salt. Yes. Give some amount. Yes. ये मोर सॉल्ट है. मोर सॉल्ट को हम लोग डिजॉल्व कर रहे हैं. मेकिंग मोर सॉल्ट. Shake well continuously. After some time, particle of Mohr salt completely dissolve in water. Then put Mohr salt in measuring flask. This is measuring flask. It has measurement 250 milliliter up to this mark. Okay, up to this mark, its measurement is 250 ml. So put Mohr salt in this measuring flask and make the level up to 250. Okay, wait. Make the level only 250. Yes. Wait. Yes. Now its level is 250 ml. Okay. ml. Now Mohr salt solution is ready. Now need to prepare more KMnO4 solution. So put water. First of all, make a small. This is KMnO4 solution. In experiment given, determine the strength of this KMnO4 solution titrating against this Mohr salt solution. Okay. Then add 6 to 7 ml H2SO4 in the KMnO4 solution so that KMnO4 solution may readily dissolve with water. Put some water. Okay. Then put KMnO4 solution in measuring flask through the funnel. Some more water is required. Okay, wait. Some more water. Okay. Means I have prepared two solutions. One is KMnO4 solution. A strength of KMnO4 solution is not given. I have made one more solution that is m by 30 Mohr solution. A strength of Mohr salt solution given, that is m by 30. So Mohr salt solution is called a standard solution, and KMnO4 solution is called normal solution. So with the help of the Mohr salt solution, I am going to determine the strength of KMnO4 solution. Okay. Now coming to set the apparatus. Now fill KMnO4 solution in Burette. Level is up to 0 level. Okay, yes. Always keep in the mind, no air bubble should be in this position. So, yes. Yes, right. Process is 10 ml of Mohr salt. 10 ml of Mohr salt in conical flask. Conical flask. Conical flask. Process is similar to experiment 1. Then we will put 1 full test tube of dilute H2SO4 in Mohr salt. Okay. Yes. Then note down what is the initial point. 0. Initial point is 0. And always keep in the mind the flow of speed of KMnO4 should be slow. Very slow. Yes. ऐसा पोजिशन में रखना. वेट देखो ऐसा एक हाथ से यहाँ पकड़ेंगे और एक हाथ से इसको सेट करेंगे. ओके, ऐसा सेट करेंगे, एक हाथ से पकड़ेंगे, so that reaction takes place in controlled manner. Actually, reaction is redox reaction, so it takes some time for the completion. इसको थोड़ा धीरे धीरे करेंगे ताकि जो रेडॉक्स प्रोसेस है वो कंट्रोल मैनर में हो. ओके. यस. partial contribution. Mohr. Slow down the flow of motion. Yes. Takes one more drop. One more drop only. One more drop. Yes. Yes. It is a reading. It is a lightning. Okay. Take one more drop. It is lightning, then what is final reading? You have to observe.
Final reading is 12.2.
Yes, 12.2.
Difference is 12.2.
Yes, 12.2. Now, throw it. Was the conical flash? Repeat the experiment. Yes. Again take one full test tube of sulfuric acid. Yes. For fourth experiment, initial is 36.6. Yes. 49 approximately. 48.8. Correct observation, 48.8.
Difference 2.8.
Difference is 12. Now, concordant volume is concordant volume equal to 12.2 ml milliliter. Means 4 observation observed. In each observation difference is 12.2 means we have done experiment very well. There is no anyone error in the experiment. Okay, now coming for the calculation. See the observation. In serial number I have written 1, volume of Mohr salt used, Burette reading, initial reading, final reading, difference, volume of KMnO4 solution used. In serial number 1, volume of Mohr salt is used 10 ml, initial 0, final 12.2, different 12.2, and 12.2 is KMnO4 used to oxidize Mohr salt. Again in second observation, volume of Mohr salt is used 10 ml, initial is 12.2, then final 12.4, then difference observed 12.2, volume of KMnO4 used 12.2, means 12.2 ml KMnO4 is used to oxidize 10 ml of Mohr salt. For observation 3, again we have to take in 10 ml of Mohr salt. For third observation, initial is 12.4, final is 36.6, and difference is 12.2. Again volume of KMnO4 is used to oxidize 10 ml of Mohr salt is 12.2 milliliter. For fourth observation, initial is volume of Mohr salt used 10 ml, initial is 36.6, final is 48.8, and difference is 12.2, and KMnO4 used is 12.2. Means that the 4 observation that is observed during the experiment, that is 12.2, all are similar, so that the concordant volume is 12.2 ml. Now coming to the calculation. This is the burette and the reading is this side. Ionic equation for the experiment. Ionic equation. Ionic equation is same that was studied in experiment number 1. KMnO4 minus plus 5 electron plus 8H plus to form Mn2 plus 4H2O. For Mohr salt, Fe2 plus to form Fe3 plus 1 electron. To equalize the number of electrons, actually number of electrons in first reaction is 5 and in second reaction is 1. So by multiplying 5 to the equation number 1, and both electrons become equal and cancel out both the 5 electron and 5 electron. Then overall reaction, it is KMnO4 minus plus 5 Fe2 plus 8H plus right side Mn2 plus 4H2O plus 5 Fe3 plus. Now, yes, for the calculation, actually we are going to get the molarity equation M1V1 equal to M2V2. Suppose that M1V1 is for Mohr salt and M2V2 for KMnO4 solution. M1 already given in the question 1/30 mol per liter, V1 equal to 10 ml that is used in every observation. M2 for KMnO4 solution is going for the calculation. V2 that we have to observe during the observation, that is the concordant volume 12.2 ml. Now from the above, from the equation, ionic equation, one part of KMnO4 is oxidized 5 part of the Mohr salt solution, so that this ratio becomes M1V1 by MC equal to 5 by 1, means value of M1 equal to 1 by 30 into A, or value of M2 going to calculation, value of V2 that is 12.2 equal to 5 by 1. Then after calculation it becomes 0.33 divided by M2 into 12.2 equal to 5 by 1, or M2 equal to decimal 33 divided by 12.2 into 5 equal to 0.33 divided by 61 equal to, after calculation it becomes decimal 0.0541 mole per liter. So it is the molarity of KMnO4 solution, means 0.00541 m is mole per liter. Okay, now going to calculate the strength. Now strength equal to molar mass into molarity. Molar mass we have to calculate it. Molar mass of KMnO4 solution is 158 gram per mole, and molarity already calculated 0.0541 mole per liter. After calculation it becomes strength equal to 0.8547 gram per liter. This is the overall discussion of experiment number 2, and thanks to the two students, Sideshwar and Shivankar, that helped a lot to me during performing the experiment. Okay, thanks to you all.